Hi everyone, in this video I'll discuss how to identify linear functions from different types of functions, and we'll try to analyze it from different sources. First of all, let's look at given some given algebraic form. Let's say if some function is given fx equals to, you cannot see it, I think, let's write it here. Let's say fx equals to x plus 2. So is it linear or non-linear? First of all, one good way to identify a linear function is you look at x. If the x is in numerator, in regular shape, normal position, not in the denominator, and the power is 1, then it is linear. Okay, so this is linear because the power is 1 and this is like this. This is a linear function. Then if I write fx equals to, let's say, just a number, let's say 2, is it a linear function? Answer is yes, because this is just some constant function, kind of some constant number. You know, if this fx, if you write y equal to 2, this is actually some straight line, horizontal straight line. This is also a straight line equation. Another way to understand it is, actually here the slope is 0, that's why you do not see the x, that's why you do not see x here. Okay, so this is also linear function. Then if I write something like let's say something like a little bit different, let's say minus 0.5 x minus 0.5 x plus 3/2, this kind of something. This is also still this is a linear function, because you can see main thing is these are just some constant number. There is a minus, no problem. There is some constant number, no problem. This is just a number, but main thing is our variable. Our variable is safe because you have, this is, the power is 1, so we have no problem still now. Okay, this is actually the actual definition of linear function is, this is actually the first degree polynomial. Still it is a first degree polynomial. Okay, we'll discuss more about polynomial in some other video. Okay, but let's just look at simple way. If you don't want to understand that, if you don't want to go through all of them, just you will look at x. Okay, let me show you some nonlinear functions so that you understand the difference. One nonlinear function is 1 by x. This is a nonlinear function because if you bring this x to the top, then this power is actually minus 1. Actually x power is minus 1 here. If you write it, this means this, so power is minus 1, power is not 1 here. So this is a nonlinear function. This is nonlinear function. Then if I write another function like fx equal to x square plus 2, this is also nonlinear function because as you can see the power is 2, which is not 1. If the power is different other than 1, then it is nonlinear. Then some other function can be, let's write something very interesting. Let's say if I write 2 to the power x, what about it? Is it linear or non-linear? Now you will say, sir, conventionally, sir, as just a while ago you said if the power is 1 then it is linear, so I can see the power is 1, so it is linear. Actually this is not linear. Why not? Because see, the x is not base here, x itself is power here, so this is not, this is also non-linear function. Actually this is some exponential equation. Let me write here non-linear. This is also non-linear. This is actually exponential, this is quadratic, so they are not linear. Okay, this is not linear, this is also not linear. Also if I write something like let's write something fx equals to x cube, this is also non-linear. Okay, power is different. If power is different, then this is non-linear. Let's write some rational kind of thing. Let's say x plus 2 divided by x minus 1, something, whatever comes to my mind, I'm just writing here. Okay, some fraction. You can write here some other numbers also. So as you can see, this is some rational. As you have seen, this, if this is 1 by x, then x becomes x to the power minus 1. This x is our problem. Okay, so somehow this x will go up, and basically then this is a negative, so this is also non-linear. This is also non-linear. These all are non-linear function actually. These all are non-linear function. Okay, so I think you have got, I can actually go on for more and more example. Let's say fx equal to square root of x, this is also non-linear. If I write fx equals to cube root of x, fx, this is also non-linear. Hey, you can ask, sir, how do I remember all these things? This is so much tough. Actually this is not tough. Look at this, here linear means the power is 1, just simple. And then if there is some constant number, this also linear. And see, all of them have some messed up, you can think this way. Okay, all of them has some like some crazy thing with them. See, cube root, square root, denominator kind of thing, then cube. So these all are non-linear. Also, if you draw the graph of non-linear, all of them graph will be curved. Okay, if you graph any of them here, all of them will be curved. This will be straight line, that's why they are called linear. Okay, this is also linear, this is non-linear, non-linear, this is non-linear, 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 I mean by this. So this way, if the equation is given, you can understand which one is linear, which one is non-linear. Now let's say equation is not given. Suppose equation is not given, suppose the graph is given. What you will do? Now look, this is simple. If you see the graph, if you see the line is straight, then it is linear. No matter where the line is, it is straight, then it is linear. Okay, this is also linear. If the line is curved, say this is non-linear because it is not a line, that's why it is non-linear. Then just a simple curve, no matter where is the curve, it is also non-linear. Okay, all of them are non-linear. If it is given in a scattered diagram, let's say this, this is actually linear. Let me write it. This is actually linear. Why it is linear? Because you see the general shape of the values is line. This is a line. See, if I draw like this is linear. Do you see this? See, all of them are on line. You cannot see them, right? That's why, because the general trend is here. See, now you can see. This is, you can see now. So this is actually linear. So what is non-linear? Okay, let's draw something non-linear. Let's say if I draw something like this, something like this. See this. This is non-linear because you can see the general shape is, see, the graph is going like that. See, downside. Do you see this? This is like this. See, the line is curved. Line is curved. This is curved. This is why it is non-linear. Suppose if I give you this way, let's say some value randomly given without any other thing. Let's say this way the values are given. What about this? Just some random points here. What about this? Is it linear or non-linear? This is actually also non-linear. No matter where it is given. No matter. Suppose this value is given here. It is linear. Okay. I mean, if the value is given here, given there, no problem in which quadrant it is given. Okay. This is non-linear. We can actually draw as much as we want. Let's say these values. What about this? Is it linear or non-linear? This is linear. See, this is a line. General shape is a line. General shape is a line. You can see this. General shape is a line. See, line. And if I ask you what will be the slope of this, so you can see this is increasing. The graph is increasing here. Okay, so the slope is greater than 0. Here graph is decreasing. This is the decreasing graph. So how do we know decreasing? Come from left to right, then you see the line is going down. Here like this, come from left to right, then see line is going down, going up, this one. So here m is less than 0. M is less than 0 means m is negative. M means slope of the general thing, general shape of this. Then m is m is negative here and m is positive here. Now let's look at another thing. Suppose graph is not given, suppose algebraic functions are not given directly, just the data are given. Then what about that? Let's say x and fx. Okay, say 0, 1, 2, 3. This is given this side, and this is given, let's say 15, 25, 35, 15, 25, 35, 45. Suppose this, then x, and then fx. Let's say something given here. Again, I can write some different number also here if I want. We can write some different number here also. Let's write something else, 2, 4, 8, 10. Then let's write here, suppose some number, 17, 19, 21, 23. Let's say this is my pen, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, let's write one more. I will discuss all three of them, x, then fx. Let's write 0, 1, 2, 3, and let's write here, suppose 3, then 7, then 10, then 15. Suppose this number, these are the numbers. We are trying to understand which one is linear, which one is not linear. You will try to find out the difference. Okay, difference. So 1 minus 0 is 1, 2 minus 1 is 1, 3 minus 2 is 1. Second number minus first number always. 25 minus 15 is 10, 35 minus this is 10, this minus this is also 10. So if you see the difference is always same everywhere, then it is linear. Okay, you will subtract them. Always second value minus first value, second value minus first value, second value minus first value. Here also both sides. If you see both sides is same, I mean difference here and the difference here is same. All number is same. All number is same. This side, both side, then it is linear. Let's look at this. 4 minus 2 equal to what? 2. 8 minus 4 equal to what? 8 minus 4. 10 minus this equals to 10 minus 8 equals to what? 10 minus 2 equals to 2. Then I'm thinking about actually this value. Okay, then this minus this, 19 minus 17 equals to 2, this minus this equals to 21 minus 19 equals to 2, this equals to 2. Now you see this side is same, but we have one problem here. This is 4, this difference is 4, so it is non-linear. Okay, this data is non-linear because the difference is not same everywhere. Although here is same, but here is not same. Okay, so this is not non-linear. This is not non-linear. This is not linear. That's why it is non-linear. Now this one, let's look at this. So this is 1 minus 0, 1, 2 minus 1, 1, 3 minus this equals to 1. Then 7 minus 3 equal to 4. This minus this equals to 3. This minus this equals to 5. So is it linear or non-linear? This is actually non-linear. Now you can say, sir, all the maths is easy, like this easy. Actually all the maths is this easy. Normally instead of x, sometimes we write something, suppose time here. Okay, suppose here growth. Okay, so time and growth. So this is the value. Then this value is given, but the method is still same. Do you understand? The method is still same. Process is still same. Suppose here I write, if I write here now the number of students, here I can write their affinity to something. Let's say if they like this or that, some other values, different parameters we can set here, independent parameter and dependent parameter. Different value, different name we can give here, but the process is same. Okay, both processes same. So this is how we can find out the differences between linear and non-linear things. This is how we can identify them. Thank you all. Thank you very much. Bye bye.